Alright, this is chain rule day 2, and we're just going to keep going with some more examples of the same rule we were doing yesterday, so nothing really new, just doing a few more practice items. So remember, we want to use our correct notation. F prime is what tells everybody that we're doing the derivative. And this can be rewritten as this, which can help when you're doing the chain rule to see that power on the outside. So we're going to bring that power in front. We're going to decrease by 1. And then we have to do the derivative of what's inside. So the derivative of cosine is negative sine 4x. You don't get to change the angle at all. That stays. And then you have to dive in one more level and go, what's the derivative of that angle? So the derivative of this would be a 4. So just simplifying now, I'm going to underline kind of these lone coefficients, so a 3 and a 4. And technically this negative 1, I can pull all of those out front and make negative 12. And then I've got cosine 4x to the second, and I've got this sine 4x. That's about it. So technically that is correct. All the pieces are there. There's no negative exponents or anything problematic. This is just kind of cleaning it up, making it look a little more presentable. Next one, going with my notation, f prime of x. And this is a product rule, so I've got these two quantities sitting here. So I'm going to take the first one times the derivative of the second. So the derivative of just this thing would be, pull the power down, 6x, plus the second times the derivative of the first. So the derivative of this, natural log, is just 1 over whatever you're logging, so 1 over x squared. And, parentheses, you'll need the derivative of what's inside. So the derivative of that is just a 2x. So now I'm just going to clean up a little bit. Normally we'll throw the coefficients and other variables out front. I've got natural log of x squared plus, I do have an x squared in the bottom and an x squared on the top, so I can just reduce those. And I'm left with 3 times 1 times 2x, which is just 6x. 2 more left. The first one's got a power, and I've got a quotient rule inside of there. That's going to be a bit much to do. Another way you could write it, if you wanted to do it as just a quotient rule, sorry, you could give, whoops, that can't be a 4, that's a 2. You could give both the top and the bottom the 4th power, and then you could just treat it like a quotient rule. And sometimes that's a little easier to look at than a chain. So a chain rule would have been take the 4 out front, all of that, decrease by 1, and you'd still have to do the quotient rule on this. So I'll write it out for you 2 different ways. I'm going to attempt to squeeze both of them in here. But I'm going to show you 2 different ways to do this. So number 1 could have just been as a straight chain. So 4 comes in front. All that stuff stays the same. To the 3rd power, that's normal chain. And you have to do the derivative of what's inside. Well, if I just looked inside, I've got a little fraction. So I have to do the quotient rule. So bottom, oh, I changed that 2 into a 3. That's a 2. So bottom times the derivative of the top minus the top times the derivative of the bottom all over bottom squared. So that is kind of how we could tackle this one. It needs a quotient rule and a chain rule kind of together. Another way to do it would just be to look at this and just start with your quotient, whoops, number 2. Boy, I'm struggling, f prime of x. So just doing a quotient rule in this, which would be bottom times the derivative of the top minus the top times the derivative of the bottom, so 4 would come in front to a 3, and you would need the derivative of this, which would just be a 1 off of the x, all over bottom squared, which we were a 4th power, so now we would be an 8. So it's kind of 2 different ways to do it. The simplifying will look a little different on both, and they might look like different answers, but they truly are not different answers in the end. Okay, so whichever method you pick, your main goal is to just get all the pieces in the right place. After that, it would be a little bit of algebra and solving. So this one, to the 4th power, you would just kind of leave this. I don't want you to multiply that out to the 4th. You could probably just get rid of this 1, because multiplying by 1 is not really a big deal. You could, since everybody's got an x minus 2, you could kind of reduce by 3. That's your lowest amount. But getting all these pieces, if you can manage to get all those correct, you are 90% of the way there. This one, both of these would need to get a cubed, and then you could start to multiply all of this numerator together and then all of this denominator together. So just two different ways to do the problem. First one was a chain rule. Second one, I could give them both the fourth power just like this and then just do a quotient rule. Last one, I'm going to change into a 1/2 power because doing the power rule is much easier when you've got an exponent. So when I go to do the derivative, I'm going to pull the power in front. I'm going to decrease by 1. And then I have to do the derivative of what's inside. So inside is a fraction. I'll have to do the quotient rule again, just like the last one. So bottom times the derivative of the top, which is just going to be that 4, minus the top times the derivative of the bottom, 3x squared, all over bottom squared. So x cubed and to the second. Our main issue here is having this negative exponent, and if you remember your rules about exponents, you can just flip this over and it will turn that positive. So I'll keep my 1/2. I'm going to flip this to the 1/2. I'll simplify here a little bit, so 4x cubed, and then minus, this will be 12x cubed, and plus 6x squared, all over x to the 6th. So that's just the beginning of what I could simplify. I could put these two together. They're like terms. I could probably cancel some x's. Just getting everybody in the right places. That's your main goal here for chain rule. And make sure you don't have any negative exponents in the end. So just give that fraction a flip, and that fixes your negative powers.